Welcome friend. Now we'll discuss high pressure boilers. Boiler is one type of heat exchanger in which heat produced by burning fuel is supplied to the water and water is converted into steam. And the steam generated at typical pressure is supplied for the process. And the steam is produced at low pressure or high pressure depends upon application. When the steam generated in a boiler is below 80 bar pressure, then boiler is called as low pressure boiler. And if the pressure of steam generated is more than 80 bar, then the boiler is called as high pressure boiler. Low pressure boiler is used to supply steam in a sugar factory. Low pressure boiler is used to supply steam in rubber vulcanization of rubber process and also used in various chemical and food processes for supplying heat. While the high pressure boilers are used to supply steam at high pressure in power plant to generate electricity. And it is a general trend to generate steam at high pressure in a power plant. And the advantage is that when the steam is generated at high pressure, the power plant efficiency increases according to Carnot principle. When the steam supplied in a power plant is at higher pressure, then efficiency increases. And this basic basis is used for the steam generation in power plant to achieve the higher efficiency. There are various high pressure boilers used in steam power plant. Lamont boiler, then Benson boiler, then Velox boiler, then supercritical boilers and supercharged boilers. So first we'll discuss Lamont boiler, which is high pressure boiler generating steam more than 80 bar, and the water is circulated through tube. So the Lamont boiler is water tube boiler and the water is circulated in a boiler at by using feed pump. So boiler is forced circulation type, and forced circulation is achieved by using external pumps, and the working pressure in Lamont boiler is around 170 bar, and the steam generation rate, evaporating rate in Lamont boiler is about 45 tons per hour at 773 Kelvin. It has various components like feed pump, economizer, air preheater, superheater, convective evaporator, radiant evaporator, a boiler drum, a circulating pump. This is typical picture of Lamont boiler in which this is air preheater and this is the blower for supplying air. Then we have feed pump, economizer, steam separating drum, then radiant evaporator, convective evaporator and superheater. Now we'll discuss how Lamont boiler is working. Boiler blower draw the cold air from the atmosphere supplied in a air preheater, where where the combustion air is heated by using the heat of exhaust gases, and slightly heated air is passed into combustion chamber, and fuel burn due to the heated air, and the heat produced is used to evaporate the water. Here we have feed pump which draw the water from hot well and supply to the economizer. In economizer, the heat from the exhaust gases are absorbed by the feed water, and feed water is get heated, and the heated feed water is supplied to the steam separating drum. From steam separating drum, this hot water is supplied into radiant evaporator with the help of this circulating pump. In radiant evaporator, we have two header lines and different tubes through which water flows and gain the heat by radiation. That's why the evaporator is known as radiant evaporator. Then mixture of water and steam enter into convective evaporator, where steam is converted into saturated steam, and that steam is supplied in a steam drum, and the steam generated is supplied to the superheater, where the saturated steam is further heated by using the heat of exhaust gases, and saturated steam is converted into superheated steam, and that superheated steam is supplied to the prime mover. So this is about the working of Raman boiler, and the exhaust gases through economizer pass to the atmosphere through chimney. Now we'll discuss advantages of Lyman boiler. Lyman boiler is compact, flexible in design. The drum used in a Lyman boiler is small in size, required low, so small pace. It generates the steam at high rate, about 50 ton per hour, and the heat transfer rate is also high in a Lyman boiler. Disadvantage of a Lyman boiler is on that on the inner surface of heating tubes, bubbles are formed and attach, which reduce heat transfer rate. Next boiler is Benjamin boiler, which is the supercritical steam generator. And this Benjamin boiler is invented by Mark Benjamin in 1922. It is also called as one through boiler because water enters at one end of the tube, and at other end of tube we are getting superheated steam, and the tube is divided into different sections like convective, radiative, and superheater section. And Benjamin boiler generates steam at high pressure and use uh, that steam generated is used for electricity generation and industrial processes. This is simple Rankine cycle on temperature entropy plane. In this, 1 to 2 is the pumping process. Feed pump supply the water, increase its pressure from condenser pressure to boiler pressure. Then 2 to 3 is heat addition in a boiler, and 3 to 4 expansion of steam in a super high pressure steam turbine, HP turbine. 4 to 5, heat addition in a reheater, and again 5 to 6 is the expansion of steam in LP turbine, and from the LP turbine exhaust steam pass to the condenser where it condenses by rejecting heat to the cooling water. And this is a saturation curve. In this saturation curve, this is the critical point. Before critical point, we have here is liquid region. Under the curve, we have liquid and vapor, and here we have superheated region. Now, under this curve, the mixture exists, means liquid is converted into vapor, and to convert liquid into vapor, we require latent heat to be supplied. But consider this process 2 to 3. In this case, the liquid is heated up to 2 to 2s or some point, and after that, the liquid is directly flashed into steam without absorbing latent heat. Means latent heat is not required above critical point because liquid is directly converted into steam. Okay, means here when we heat the liquid along this curve, liquid is converted into steam without latent heat. And when the boiler is working at a pressure and temperature more than this critical point, then the boilers are called as supercritical boilers. And when the boilers working at a pressure and temperature below this point, then the boilers are called as subcritical boilers. So what is critical temperature and pressure? The critical pressure is 22.1 megapascal, mean 2 to 1 bar, and critical temperature is 374 degrees Celsius. When the pressure and temperature of boiler are more than these values, then the boiler is called as supercritical. If these values are low for the boiler, then the boiler is called as subcritical. And when the boiler is operating at these values, then the boiler is called as critical boiler. So this is the Benjon boiler, which is supercritical boiler, uh, which generates steam above 221 bar and temperature above 374 degrees Celsius. And this is the drumless boiler and overcome the disadvantage of Lyman boiler of forming bubbles in the tube and reducing heat transfer rate. So in this case, again, we have different component like a blower for drawing cold air and supply it in air reheater, and then combustion chamber. Then we have feed pump for supplying water to the boiler. Then economizer, radiant heater, convective heater, superheater, and the drum, that shell. This is the drumless boiler, water drumless boiler. Now we'll discuss how Benjon boiler works. So this blower draws the cold air from the atmosphere supplied to the air preheater, where this cold air is get heated by absorbing heat from the exhaust gases flowing to the chimney, and this heated air pass into combustion chamber where it is used to burn the fossil fuel, and the heat liberated by burning the fossil fuel is used to generate steam. This is a feed pump which draw the hot water from hot well and supplied into economizer, In economizer, feed water absorb heat from the exhaust gases and get slightly heated, and then feed water supplied to the radiant heater, where some water evaporate and we have the wet steam is formed in radiant evaporator. This mixture of water and steam further flow into the convective evaporator where it absorbs heat and completely converted into saturated steam. This saturated steam further enter into superheater, and by absorbing heat from the hot gases, the saturated steam is converted into superheated steam, and the superheated steam is supplied to the process or supplied to the HP turbine for electricity generation. So in Benjamin boiler, you can see that water enter into the tube of economizer, then flowing through radiative tube, convective tube, and superheater tube. So water is enter at one end of tube, and at other end we are getting superheated steam. That's why the Benjamin boiler is called as one through boiler. So Benson boiler is a water tube boiler for circulation, high pressure boiler. Pressure is about 2 to 5 bar up to 500, 600 bar, and temperature is also high up to 650 degrees Celsius, and steam production rate of Benson boiler is also high, and it is 150 tons per hour, and it is used in power plant for generating electricity. And the advantages of Benson boiler are it is light in weight, easy for transportation, and it overcome the problem of Lamont boiler and avoid the reduction of heat transfer, and it is supercritical boiler, and its thermal efficiency is nearby 90%, and it requires less space. These are the advantages, and disadvantages are the feed water enter into tube and converted into superheated steam. So the salt dissolved with the water or get deposited on the surface of tube and reduces heat transfer rate, and the sediment is formed on the inner surface, and due to that the overheating of tube at localized problem occur, which is uh, dangerous for the safe working of Benson boiler, and which may damage the tube. Now third high pressure boiler is a Loeffler boiler. A Loeffler boiler is a closed vessel in which water or other liquid is heated and the steam or vapor is generated and is superheated and gets pressurized. The main working principle of Loeffler boiler is to evaporate the feed water by use of superheated steam from a superheater. Loeffler boiler is four circulation type. It is high pressure and water tube boiler with internally fired furnace. So this is the arrangement, typical arrangement of Loeffler boiler. In this case, we have air is fan or blower which supply atmospheric air pass into air treater in which air is heated by taking exhaust gases, heat from the exhaust gases. And this is feed pump which draws water from uh, hot water well and supplies to the economizer, supplies to the economizer And in economizer, the feed water absorb heat from the surrounding exhaust gases, and the heated water is passed into this drum. Now the this water is uh, served by the steam separating pump and supplied into radiant heater, where the steam is generated, and that steam generated is supplied into superheater, where it is further heated, and the heated steam is used for the electricity generation in power plant. The superheated steam generated in a superheater is partly supplied to the steam HP turbine and partly supplied to the that drum. Around one third of steam generated is supplied to the turbine, while two-thirds of steam generated is used to generate steam in this drum. So in a Loeffler boiler, steam is generated from the superheated steam, and around two-thirds of steam is again supplied to uh, heat the water to generate steam, and by supplying this superheated steam, the saturated or wet steam is produced, and that steam uh, is supplied to the radiant surface, radiant heater and superheater by this steam circulating pump. And the disadvantage of Lyman boiler are overcome here because the water is not evaporated in the tube. In this case, water is evaporated in the drum and only steam is circulated. So the salt dissolved in the water are get collected into this evaporator drum, and we can drain out the sediment or salt associated with water. And this overcome the drawback of Lyman boiler as well as the Benjon boiler. And it has a different component which we have already seen, that economizer used for preheat of feed water, then evaporator drum in which the water is evaporated from the superheated steam, steam circulating pump which circulate the pump steam from the evaporator drum to the radiant and superheater, and then we have radiant superheater, convective superheater, and the mixing nozzle for the mixing superheated steam to feed water. The working we have already discussed. So this gives the working. The water enters the boiler through feed pump, which is forced into economizer to increase its temperature by heat from flue gases. Then the heated water goes into evaporating drum, where the heated water gets converted into saturated steam by action of superheated steam from superheater. Then the saturated steam passes through the radiative superheater and consecutively to convective superheater. The temperature of steam is increased and it gets superheated. Two-thirds of superheated steam enter into evaporating drum through nozzles and mixes with heated water. This increases efficiency of boiler, and the remaining one-third steam is sent to HP turbine for power generation. The Loeffler boiler has capacity to produce 100 tons per hour of steam, and its working temperature is 500 degrees Celsius. Working pressure of Loeffler boiler is around 140 bar, and the efficiency is high, up to 90%. Advantages of Loeffler boiler: can use salt water for steam generation. The problem of deposition of sediments and scale of previous two boiler, Benjon and Lemon, are eliminated. It is compact inside. Its operation is silent and clean and capable to react rapidly to sudden variation of load. These are the advantages. Disadvantage: bubbles are formed at inner face of heating tube, which reduces heat transfer rate. Evaporating drum increases the cost of boiler. These are the disadvantages of Loeffler boiler. Now next boiler is Velox boiler. Velox boiler is a high pressure water tube boiler. It is for circulation type, mostly used in gas turbine, and it is most important and mostly wide used boiler. This shows the uh, picture of Velox boiler, which consisting of fuel tank, fuel pump, then we have combustion chamber, then there is feed water tank, economizer, steam separator, then here is water tubes, superheater, uh, gas turbine, and axial flow compressor for compressing air. This fuel pump supplies fuel with the pressure into combustion chamber, and that fuel burn with the pressurized air supplied by this axial flow compressor. Around 2 to 3 bar the combustion takes place, and due to increase of pressure of air velocity increases and heat transfer rate increases from few gases to the water in the water tubes, and the exhaust gases then enter into superheater, where the exhaust gases heat the steam to superheated condition. Now the water from the feed water tank enter into economizer by feed pump and absorb heat from the exhaust gases which are coming from the gas turbine into economizer. Now slightly heated water enter into steam separating drum, and from that water enter into water tubes, where this water absorb heat from the hot gases by radiation and convection mode, and that hot water enter into this drum where steam is get separated, and that separated steam flows to the superheater where it is further heated to superheated condition, and superheated steam is used for process, and the exhaust gases from the superheater enter into gas turbine, which run the gas turbine, and the power developed by gas turbine is used to operate the axial flow compressor. Axial flow compressor compresses the atmospheric air and supply to the combustion chamber at 2 to 3 bar. Because of compressed air, because of pressurized air velocity increases and heat transfer rate increases in the Velox boiler, and combustion takes place at high pressure 2 to 3 bar, and the exhaust of gas turbine is passed to the economizer, and from the economizer exhaust gases escape to the atmosphere. So this is the working of Velox boiler. When the velocity of gases is in higher subsonic or even supersonic region, the rate of heat transfer increases significantly in combustion chamber. This boiler can increase the heat transfer rate or can say steam generation rate without increasing boiler size. This is why Velox boiler is most successful boiler in gas turbine industries. This boiler has high heat transfer rate. It has great flexibility. It is compact in design. It has great thermal efficiency, about 90 to 95%. Next is supercritical boiler, which we have already discussed. When the steam generation rate and steam temperature and steam pressure is more than critical pressure and critical temperature, then the boiler is called as supercritical boiler. A supercritical steam generator is type of boiler that operate at supercritical pressure, frequently used in production of electric power. And the supercritical pressure is that critical pressure is 2 to 1 bar, and if pressure is more than that, then boiler is called as supercritical boiler. And it is also required temperature more than 374 degrees Celsius. Critical point in water vapor cycle is a thermodynamic state where there is no clear distinction between liquid and gaseous state of the water, means latent heat is not required. Liquid is directly converted into vapor, and the latent heat component is not required. That's why efficiency increases in a supercritical boiler. And typically critical pressure for water is 221 bar and 374 degrees Celsius. Another boiler is supercharged boiler. In supercharged boiler, surrounding air is drawn by axial flow compressor, which compresses the air, and the compressed air is supplied in combustion chamber. So in a supercharged boiler also, fuel is burned under pressurized condition more than the Velox boiler. And we have already discussed, when the pressurized air is there in combustion chamber, the air velocity increases and heat transfer rate increases in convective, radiative, and superheater. So in a supercharged boiler also, we have axial flow compressor which supplied compressed air in combustion chamber. In this supercharged boiler, we have air water feed pump which draws the water from hot well supplied to the economizer. In economizer, this feed water take the heat from the exhaust gases going to chimney, and slightly heated water further flow to the this ET1, evaporative tube 1. In evaporative tube 1, the water gain the heat by radiative and convective mode, and then the water is converted into steam, and the mixture of water and steam is then enter into the tube 2, and from the tube 2 the wet steam is passed to this boiler drum. Now the wet steam means steam and water. The water portion is again passed to the ET1 by this feed pump, and the steam form produced is passed to the superheater. In superheater, this dry saturated steam, is further heated to the required temperature, and the superheated steam, is passed to the HP turbine. And the exhaust gases, exhaust gases from the superheater are passed to the gas turbine, and these exhaust gases at high pressure expand, means the typical pressure may be 10 bar. The gases expand from that pressure to low pressure and develop work, and that power developed by gas turbine is used to operate this axial flow compressor, which compresses the air required for combustion, and the exhaust of gas turbine is passed into economizer, and from economizer the exhaust gases are leaving the boiler. So this is the working of supercharged boiler. Supercharged boiler have a more efficiency. So this is the working of supercharged boiler, and the gases coming out from combustion chamber are passed through gas turbine, and the hot exhaust gases from gas turbine are further used in preheat of the feed water in economizer, and the typical pressure of gas is 5 bar, and pressure to steam side of 200 bar are generally prepared. It can easily meet the variation of load. This is the advantage of supercharged boiler. The total heating surface area required is 25% less compared to other boilers. This is because the combustion takes place at high pressure. Means compressed air is used for in combustion chamber. So the area required for the combustion chamber is reduced by 25%, and the heat transfer rate is increased due to the high pressure of exhaust gases. It can generate steam from start in a very short time, about 25 to 30 minutes. These boilers are constructed to generate steam of very high rate, around 2 lakh kg per hour, up to pressure of 180 bar. Small heat storage capacity of boiler plant gives better response to control. The part of gas turbine output can be used to drive other auxiliaries in this boiler. The number of operators required are less than conventional boiler in supercharged boiler case. The high pressure gas passages should have enough tightness and so that the changes of leakages are less. Thank you. So this is the video about high pressure boilers used in power plant for generating electricity.